This video is over topic 6-3 in algebra over parallel and perpendicular lines, day 2. So for example 1, they have already worked out the top part for us, so we're going to chat about what they did and then work out the bottom. So for example 1, they ask us to use the equation below to answer the following. We have 5x minus y equals negative 10, and they're asking us to write equations in slope-intercept form and standard form that are parallel or perpendicular. Now, if you remember from yesterday, the only way we can know if something is parallel or perpendicular is based on the slope. In order to find the slope, we need things in y equals mx plus b or in point slope form. So on this left side, they took the original equation and they solved for y in order to find the slope. In order to solve for y, they moved x to the other side through the opposite operation, which is subtraction, and then divided everything by negative 1 because y was not completely by itself, and then came up with two positives. And now it says we must solve for y first before we can steal the slope. So on the top right, they ask for an equation in slope-intercept form that is parallel and goes through that point. So to refresh our memory, parallel lines have the exact same slope. So my slope here was 5 for this line. For my new line, it will still be 5. I use my new point of 5, 4, and my slope of 5 because it's parallel, and plug into point slope. So y minus y1 equals mx minus x1. Distribute 5 times x, 5 times negative 5, and then add 4 to both sides to get my final new equation. On the bottom, they're asking us to ramp it up quite a bit. Not only do they want this in standard form, but they want it to be perpendicular. Now remember over here on the left side, my slope was 5. So a perpendicular slope is a complete opposite, or a flop. So positive turns to negative, 5 over 1 turns into 1 over 5. So again, I have a point and a slope. I'm going to label my point x1, y1, and plug into point slope. So y minus y1 equals mx minus x1. Excuse me. Now, to refresh our memory, standard form, x and y are kind of together. Not kind of, they are together. X and y are on the same side together. So we need x here, y here, and then we also remind ourselves that there cannot be fractions. So remember, standard form is like the super persnickety, uppity, specific form. It doesn't like numbers to be on the same side as x and y. It doesn't like fractions, so it's very specific. So first thing I'm going to do is distribute. So negative 1/5 times x, negative 1/5 times negative 5. And then I'm going to move 4 to the same side for my numbers. So y equals negative 1/5 x plus 5. Then I'm going to move x because remember in standard form, x and y are next to each other. So we have 1/5 x plus y equals 5. And then my final step to get this in standard form is to get rid of my fraction. Right now, x and y are right next to each other on the same side. I have my number that's not an x or a y on the other side. And now I have to get rid of the fraction. So I multiply everything, all of the pieces, by the denominator of 5. So my 5's cancel on the x's, and I have 1x. 5 times y is 5y. 5 times 5 is 25. And that is in standard form. So remember, perpendicular is a complete opposite slope. If it asks for it in y equals mx plus b or slope-intercept form, we could stop at the red, but they ask us to put it in standard form, so we have to take it 2 more steps down the line. Example 2 has been done for us. They give us an equation, x equals 3, and ask us to answer what the slope is. Well, x equals 3 would be a vux, so that would have an undefined slope. My line is drawn down here for me, x equals 3, and it is parallel to the y-axis and perpendicular to the x-axis. Remember, parallel means the same slope. So with special cases, if you start with a vux, parallel would also be a vux. Vux means you take x equals your x point and you're done. Perpendicular to a vux would be a HOI. So my options here are vux or HOI, whatever you start with. Parallel would be the same, perpendicular would be the opposite. So for this one, the opposite of a vux would be a HOI. So a HOI has a slope of 0, and my equation is a y equals equation. So if we look down at example 3, they're giving us the equation y equals -5. So remember that y is a HOI equation. The slope is 0. And when I draw it, it is a horizontal line that goes through the y-axis. If it is going through the y-axis, it will be perpendicular to the y-axis and parallel to the x-axis. So on both of our special cases, perpendicular is the same letter because it has to go through the axis of the letter that it was given. So parallel for HOI would also be HOI. So my slope will still be 0. My equation will be y equals the y in my new point. And then perpendicular to a HOI would be a vux. So my slope would be undefined and my equation would be x equals 3. So with special cases, whatever you are given, parallel would be the same type, perpendicular would be the opposite type.